Hey everybody, Trey here. Welcome back to another update on the forecast for today's severe weather threat across parts of the Midwest. The SPC has maintained a slight risk, level 2 out of 5, across parts of southern Michigan into much of Illinois, Indiana, and Ohio, down into the Ohio River Valley region. All hazards on the table for today. We'll zoom in here for you and get some of those hazards. Tornado threat is at a 5% level. You see within the slight risk area there, much of eastern Illinois, all of Indiana, western Ohio, down through the Ohio River Valley. So tornado threat is there, although there are some questions regarding how much that tornado threat will play out today. Damaging wind is going to be a threat, as well as large hail. We'll zoom in here and show you that there is a 15% hashed area for significant severe hail, perhaps over 2 inches in diameter. That does include places like Chicago, Peoria, Illinois, Indianapolis, Evansville, all those areas under the gun for the greatest severe hail threat today, as well as the tornado threat. So definitely an active day. Gonna have to make this video quick as I have an appointment to get to this morning, but at least wanted to put up a video since we have some new data since our last video a couple days ago. So I thought it would behoove us to go over some of the data and how things have changed just a little bit since the last video. All right, let's go ahead and dive in here. We'll start off with our 500 millibar map. Once again, as we talked about in our previous video on this setup, we have this kind of split flow regime across the continental U.S. We have this belt of strong flow located down here to the south, associated with our subtropical jet, that band of the jet stream that is situated closer to or a little bit farther south. And then we have our polar jet that is spitting out this little trough up here, digging into the northwestern quadrant of the country. These two, as we said, are going to try to phase over the next day or so. They're not going to be able to completely phase, though, by the time this event gets underway. So we're going to have a little bit of a wonky configuration in the mid to upper levels as far as the jet streams go for this setup. But we still have enough support in the upper levels to support a severe threat across these regions. And this belt of flow, the subtropical jet band of flow, will continue to move off to the northeast, and this trough will continue to dig down a little bit here into the central U.S. And overall, that will be the main forcing mechanism taking over for the overnight threat into Wednesday's threat, which is at a low-end risk right now. I believe they've introduced a marginal risk for tomorrow. Yeah, just a little bit of a marginal risk to cover the maintenance of the storms into the morning, early afternoon hours tomorrow across the Kentucky region. So let's go down to the surface. And this was an interesting one. We talked about how this surface low was going to be, surface cyclogenesis was going to occur up here in Canada, as that is where our biggest, our best spin in the atmosphere is, traversing the Rockies up there. So we got least cyclogenesis up here to the northwest, dropping down to the southeast. So here's our current surface low. So unlike a typical event where we'd have cyclogenesis out here across the southern plains, we had it up here across Canada, and that has dropped to the southeast. Current surface low positioned somewhere in far southeast Minnesota, it looks like. Cold front draped down well to the south through the pressure tongue. There we do have a little bit of a secondary surface low center, possibly out here across eastern Colorado, but that will not really have any impact on today's event. So we've already seen so we had an initial surface low a little bit farther to the north, regenerated somewhat down here in the Dakotas, and has moved off to the east. And this will be our main surface low for this event. But it doesn't look all that tightly wound. You see just a broad circulation here across much of the central plains into the Midwest. Not really that very tightly wound, lots of isobars right together surrounding a surface low that we'd often see with a big event. So the low-level characteristics, the low-level response has been a little wonky with this one as well. Wonky trough in the mid-levels, wonky surface low development down here in the low levels, but it is still going to be enough to, number one, bring all this moisture northward, and we're a little ahead of schedule with the surface moisture. If we take a look at our current raw surface data, you see the 60s dew points are already up into southern Illinois. A lot of the models a couple days ago had the moisture, still the best moisture, the 60s dew points, sitting well off to the south at this point, but we've seen that the moisture is a little bit ahead of schedule. And we should probably have no problem now getting 60s up here into northern Illinois, northern Indiana, across that region. So that is a positive in terms of severe weather. However, that may be offset a little bit, this slightly better moisture, by, number one, how shallow this moisture is. We'll take a look at some soundings here in a second. The moisture is very, very shallow, not quite very deep moisture as we usually see in big events. And number two, we should have some heating and mixing across this region. We look at our visible satellite, pretty decent amount of sunshine across this region. That will allow surface heating to commence here over the next several hours as that moisture streams northward. But as that moisture streams northward, we're going to get heating and mixing. So there's a little bit of drier air aloft, as you'll see on the soundings. That heating and mixing can allow the air from aloft to mix downward to the surface, bring some of that drier air down. So I do expect, even if we do get initially 60s dew points up here into northern Illinois and Indiana, that we will mix down a little bit, probably back into the upper 50s, maybe around 60 at best. But I do think we will see a little bit of a decrease in dew points, even with fairly strong low-level moist advection with this system. Up at 850 millibars, a little bit of the same thing here, just a broad kind of cyclone here impinging into the northern U.S. Stronger-ish flow here around the base of this cyclone out of the west, interestingly enough, and I think it'll probably stay that way. The low-level jet probably will not start to increase up here across the main target area until later this evening when we have that nocturnal increase in low-level jet. A little bit of a stronger, more tightly wound low-level cyclone developing as the trough takes on a little bit better orientation in the overnight hours, and that's when the low-level jet should increase. So any storms ongoing in this area may start to pose a bit of a tornado threat, especially any more discrete activity overnight as the cold front takes over, even though that will allow for storms to have a tendency to organize themselves into more bands or lines going into the overnight hours. So here are some of those soundings. As you see here, this is Norman. Let's go up to Topeka and show you the profile here. And you can see a very thick layer of steep laterite aloft. This is a very strong elevated mixed layer, or EML, that has been advected out here across the central plains into the Midwest this morning. And given that we have somewhat of a lack of strong forcing, again, the trough is going to remain farther back here. The main trough is going to remain farther back from the actual target area. So we're going to be left with this belt of strong flow from the subtropical jet to start impinging on the region. Perhaps a few little kinks rotating through there to help things get going, but the forcing overall will not be all that strong initially, so that is going to give us maybe a little bit of pause regarding how much this cap will erode. This is a very stout capping inversion, extremely strong warm nose here thanks to that strong elevated mixed layer aloft. So I do expect that we might continue to struggle with low-level thermodynamics even into the afternoon as moisture increases and as heating increases. So we'll have to see how that plays out. I do think we'll probably need the surface boundaries and surface low to get storms to go. If there are any little more consolidated surface low centers within the kind of spread out, broad, banana-esque low, that will help things. Winds will be nicely back. Convergence will be a little bit stronger out ahead of that surface low and along the warm front as well. A little bit stronger convergence. It'll be a weak warm front, very diffuse frontal zone there along the moisture gradient, but that will be perhaps just enough to help overcome that capping inversion. And I think that's where our initial storms will form, is along that warm front ahead of the surface low, where convergence is a little bit stronger to help overcome perhaps somewhat more unfavorable low-level thermodynamics. And again, the moisture is shallow. We're not in the moist layer here at Topeka. Let's go down to Springfield. We'll be closer to the moist layer. Yeah, getting a little bit closer here, 59 over 52 at 7 a.m. this morning here. But you can see that moisture is shallow. The 52 dew point there at the surface, and then you immediately get that dew point line to veer off to the left, meaning very, very dry, warm, dry air here in the low levels. So again, I think that's going to be a little stubborn to erode, given somewhat nebulous forcing for ascent. And we're going to have to just wait and see how that plays out. And that may allow storms to remain perhaps somewhat elevated. We will have enough forcing to get storms to go, especially with the strong warm advection regime. But if we have unfavorable low-level thermodynamics and this cap can't erode fully, then we may have some problems getting surface-based storms, perhaps except right ahead of the surface low and right along the warm front, which would be our favorite corridor for surface-based convection with all severe hazards possible. Wind profiles here this morning, very strong down to the south. Strong, long hodographs indicative of a strong effective bulk shear. You can see a little bit of curvature there in the low levels of the hodograph indicating that warm advection. We go up here to our actual target area, Lincoln, Illinois. Much of the same, very shallow moisture, very steep lapse rates aloft, indicative of a strong elevated mixed layer. So again, that moisture in the low levels, very, very shallow with a lot of warm, dry air above it, might mean that our low-level thermodynamics are going to be a little bit unfavorable for this setup. All right, let's take a look at some model data here. This is our 12Z NAM. We're just going to look at the NAM for this video. I know we looked at our multi-model approach for our last video, but in the interest of time, let's go ahead and just take a look at the NAM for this particular setup. This is the 12Z NAM coming in as I'm recording this video. We'll start at 500 millibars here, and there's our split flow regime that we talked about. Subtropical jet down here, trough from the polar jet moving down into the northwestern U.S. And as we go through the day, those two are going to try to come closer together, try to phase a little bit. Here we are by 0Z, 6 p.m. Central Standard Time tonight, and you see we still kind of have two disparate objects here. This trough digging down into the central U.S. and this band of strong flow associated with the subtropical jet. So the phasing not quite going to be perfect here. If we had phased these two a little bit earlier and had one big trough, as we're going to see overnight, you'll see as we go forward, the trough is going to start to phase a little bit better with this low-level jet and take on a little bit, or this low-level belt of stronger flow, excuse me, is going to start to phase a little bit better together, and we'll get a little bit more favorable trough orientation. But the severe weather threat tomorrow, again, is going to be on the low side because we don't have the other ingredients there. But for today, we're going to have a little bit of a wonky setup here, and we're going to have to rely more on this kind of straight jet streak here. We are in the northeast quadrant of this jet streak, so we will have a little bit better rising motion here out ahead of the core of the jet streak for that synoptic scale forcing for ascent. And the 700 millibar map is showing a little bit of a short wave moving through. This is about 21Z. You see a little bit of kinkiness, if you will, in the height contours there, impinging into Illinois with that strong flow to its south. So that could mean a little bit of a short wave moving through, which should be enough to initiate storms, although is it going to be enough to overcome any unfavorable low-level thermodynamics that are still in place across the warm sector? I'm not sure. That remains to be seen. And so I think, again, areas along the surface low and surface warm front are going to be your best areas for storm initiation initially because of a little bit stronger convergence along those features. So that shortwave moves through, probably starts to allow storm coverage to increase going into the nighttime hours, especially as the cold front comes through. Here's our low-level jet going through. You see that low-level jet displaced a little bit to the south for most of the day, and then by evening we start to get that plume of stronger flow developing as the slightly stronger, slightly more intense low-level cyclone takes shape. We get a little bit stronger low-level flow there to increase the low-level shear going into the overnight hours for any storms that continue to move across to the east or southeast across Illinois into Indiana and Ohio. Let's go down to the surface, see how our surface low is going to progress. So here we are, 12Z, 6 a.m. Central Standard Time this morning. Here's our surface low. We'll keep it on the broad view for now. So it is centered here somewhere over southeast Minnesota this morning. We continue to move off to the east. And again, it doesn't really consolidate all that much. Tries to consolidate a little bit more, perhaps, but it's still somewhat strung out. Not really that, again, that tight, very tightly wound surface low that you see with the big events out here in the Midwest. Here we are. This is at 21Z, so 3 p.m. and 0Z. Still remains that strung out type feature. If we zoom in here, we'll try to look for any stronger little surface low centers in here. Not really seeing any more defined centers within this broader surface low. So if we had a little bit stronger of a center, as the NAM was predicting a couple days ago, had a little bit more circular, a little bit more tightly wound surface low, which would create more backed winds out ahead of it, a little bit stronger convergence, and therefore a better chance for any storms to develop along that stronger surface low center that the NAM had earlier in its runs. But now, not so much. I think we still have enough convergence here in the low levels to foster storm development, especially along the moisture gradient, which the warm front's a little bit tough to figure out where it is. We don't see a very well-defined wind shift here. So it's probably just going to be that diffuse moisture gradient that we talked about here, and that's a little bit tough to pinpoint. The actual, you can call this somewhat of a dry line feature here. Definitely a moisture gradient in there. Actual cold front back in this region here. And so our surface low centered somewhere in this vicinity here. Again, very broad in nature. So the warm front is a little bit tough to tell where that is. Probably somewhere right in here. Again, drawing this just a little bit weird. You'd have to disregard the colder air over the lake there. But the warm front probably somewhere in the very diffuse warm front, probably somewhere in there. So right at our triple point out ahead of the surface low is where storm initiation is expected initially along that warm frontal boundary just ahead of the surface low. Probably initially this afternoon. It looks like there's a little bit more confidence in storm formation this afternoon across west central to northwest Illinois, right ahead of the surface low and right along the warm front. And so that should be where our storms initiate. And then later on, as the cold front comes surging through in the overnight hours, it'll take over this dry line feature and probably increase the coverage of storms along it. Very tight gradient there. Extra convergence along that cold front likely will foster a more linear organization to the storms going into the overnight hours tonight. But still, with strengthening low-level shear, we could see the tornado threat continue into the overnight hours within the line. So that will be kind of the progression of how these surface features will go in this event. Let's take a look at some soundings here. We'll start at 21Z, right out ahead of the surface low / warm front. We'll take one in the warm sector just to show you that the warm sector may be a little bit more unfavorable. So this is the NAM. Right off the bat, again, with the NAM, we have to remember that it does tend to have a cool bias. So surface temperatures tend to be a little bit too cool in the NAM runs. Earlier in our last video, we were seeing low 60s temperatures, which was just asinine, frankly. But now we're seeing 66 over 61 here at 21Z. Number one, I think those surface temperatures are probably going to be too cool. We'll probably be in the 70s at this point, or approaching the 70s. And I think 61 degrees, again, this is at 3 p.m. Central Standard Time, so we will have had quite a long time for surface heating and mixing to take place. I think the 61 dew point might be a little bit on the high side as well. Would not be surprised to see dew points around 57, 58, 59 by this point, given some mixing going on. But even if we get to 70, this capping inversion is still pretty stout. Left over from this morning, that very strong elevated mix layer aloft, being a little bit stubborn, given somewhat weaker, more nebulous forcing for ascent. So it's going to be a little bit tougher to erode that cap. So even along the warm front near the surface low, we're seeing that capping inversion take place. And even if we were to modify this sounding for a little bit better surface temperature, say somewhere in there, we'd still have a profile that looks like this with a bit of capping to deal with there in the low levels. So that is something to keep in mind with this setup, that the capping inversion, low level thermodynamics are a little bit more unfavorable with this environment. And you can see how shallow the moisture is as well. Even if we were to have 61 dew points at the surface, they only extend up to maybe about 900 millibars at most, not even a full kilometer into the atmosphere, which is very, very shallow. It means some dry air aloft. Dry air aloft tends to sap the instability a little bit, and we won't get into that too much here in this video, but there's been quite a bit of research recently on something called E-CAPE, which factors in that dry air tending to decrease instability on the whole in these kind of drier environments. So that is something to keep in mind. We do see about 1,000 joules per kilogram mixed layer CAPE, so storms that do go will have a tendency to be somewhat robust, but with that low-level thermodynamic, poor low-level thermodynamics down there, that may be somewhat of a mitigating factor for surface-based development. Initially, once again, long hodographs, mostly straight, a little bit of curvature there in the low levels of the hodograph, but this is mostly a hail hodograph, especially if storms are elevated above that little curvature. Purely straight hodographs, it looks like, above that that low-level inversion. So storms that do fire may have a tendency to be a little bit elevated initially. And this is down in the warm sector. You can see it's even worse. Moisture is a little bit better, closer to the moisture source, but that warm nose is pretty strong, and I think the warm sector will remain capped for much of the afternoon. We're going to have to wait for that cold front to come in for more robust development to occur down to the southwest into central and southern Illinois, down into southeast Missouri. We move on to 0Z. We'll see how things have changed. So let's take another sounding right out ahead of the surface low, and we'll take another sounding in the warm sector to see how things have progressed there. So this is the surface low, and we see now we have a bit better environment across this region for surface-based supercells. Much better low-level curvature in the hodograph, stronger veering and strengthening winds with height over 300 meters squared per second squared, effective storm relative helicity. That low-level jet starting to ramp up at this point. And we are almost fully destabilized. A little bit of a surface inversion possible there. Again, this might be a little bit too cool, 60 degrees at the surface. This is at 6 p.m. Central Standard Time. That might be a little bit too cool. So that may negate any surface inversions here altogether. But very nice looking profile, about 2100 joules per kilogram mixed layer cape. Very impressive instability for this time of year up in the Midwest. Very steep lapse rates aloft. So again, we're going to have to wait and see. If we can get fully destabilized, we will have surface-based convection, and this would pose the threat for all hazards up there along the surface slope. Tornadoes, hail, and if they remain elevated, the hail threat would be larger, as we'd be elevated above this strong low-level shear. So our effective photograph would look something like that, just purely straight, with robust instability in the mid-levels at the freezing level. That would foster large to very large hail. That's why we have a significant hail threat out for today. Warm sector remains capped a little bit down south, but as the forcing slowly continues to increase through the evening hours into the nighttime hours, that cap will try to erode at least a little bit. But down to the south, that warm sector looks to remain a little bit capped as we go into the overnight hours until the cold front arrives. We'll go to 3Z, 6Z here. We'll just take a couple soundings. This is at midnight, just after midnight, or right around midnight tonight. Here, we'll take a few soundings ahead of the cold front, which will be surging off to the east or southeast here. This will continue the favorable environment for mostly damaging wind and a few tornadoes through the overnight hours. Any more discrete convection will have that better tornado threat, but assuming we will have stronger frontal forcing coming in, and our shear vectors will be oriented more parallel to the cold front, should be more of a damaging wind and brief spin-up tornado threat within any bands or a squall line that develops. Down here to the south, much of the same. Strong low-level shear, enough instability. Not much of an inversion to speak of. That low-level moist layer is deepened a little bit with continued moist advection, so that should foster a threat for that tornado threat as we go into the overnight hours, moving east into Indiana and eventually into possibly Ohio, although instability will decrease the farther east you go. And then the threat will continue into tomorrow morning with a very low-end threat into tomorrow morning across southern Indiana, Kentucky, Tennessee, along the cold front for any convection that remains along the cold front. Let's take a look at some convection allowing models here. We'll start off with the 12Z HRRR. So here we are. We might see a couple of rumbles of thunder here throughout the day across the Midwest. Those will not really impact our setup at all, mainly just a marginally severe hail threat at best. Then we go into the afternoon hours. Storms start to develop here right around 23Z. This is on the HRRR 23Z, so this would be 5 p.m. Central Standard Time. And I always like to subtract an hour or two off of those, so we could see storm development as early as 3 to 4 p.m. This afternoon. And we do get a few supercells right away along that moisture gradient ahead of the surface low. These are nice discrete supercells initially, so those would pose a large hail threat initially before transitioning to perhaps more of a tornado threat if they can stay surface-based. That's the big question. If we have unfavorable low-level thermodynamics, then we may have a tendency for these storms to remain elevated. Let's pick a sounding here out ahead, just to the east, south, and southeast of these storms. And the HRRR is on the in the camp where the low-level thermodynamics remain a little bit unfavorable for surface-based activity. 64 over 60 at the surface. So we do have a little bit of a low-level inversion to deal with that could thwart the tornado threat with these storms, despite very strong low-level shear. Beautiful-looking photographs there for a tornado threat, given strongly veering and strengthening low-level winds with height, almost 300 meters squared per second squared, effective storm relative helicity, strong deep layer shear for supercells. But if we have this surface inversion in place, I think that may be difficult to maintain surface-based supercells. Storms would be elevated, hence posing more of a large to very large hail threat rooted above this strong low-level shear. But we'll have to see how that plays out. It's a little bit up in the air at this point. We'll have to see how much mixing we get through the day, and how much we can get that cap to erode through the afternoon hours into the evening. But nonetheless, we do have storm initiation ahead of the surface low along the cold front. Warm sector remains dry. Those continue off into the Chicagoland area, going over the lake at this point. Cooler air over the lake may thwart things a little bit, and you see storms get pretty messy pretty quickly there, and I think the tornado threat should subside as the storms pass over the lake. And then they move into southern Michigan. Could see some spin-up tornadoes and damaging winds with those storms, some large hail with any more discrete updrafts as the storms move into Michigan. Then we get additional development down here to the southwest along the cold front, Missouri into Illinois and Indiana. Overnight, these quickly transition into more of a linear organization going into the morning hours tomorrow, with a marginal severe threat moving into the Ohio River Valley. How about our WRF ARW model? So here we go. Here's just another model we'd like to use. Storms do initiate right around 0 to 1Z, so 6 to 7 p.m. Again, subtract an hour or two, so 5 to 6 p.m. They are looking supercellular here initially across northern Illinois, and then you can see they weaken as they go right over the lake, which is not all that uncommon given the cooler air coming in off the lake and over the lake. So we should have some, at least a brief window for discrete supercells with maybe all severe hazards. Tornado threat, again, dependent on the degree of destabilization in the low levels. But then things will transition into more of a messy mode moving into Michigan. Spin up tornadoes, damaging winds possible there. And then additional convection forms along the cold front farther south into the overnight hours into Wednesday morning. NSSL WRF, one more cam we will look at this morning. And not much through the day. Then we again get development out here across northern Illinois. This is at 2Z, so even later than the other two models, surprisingly. And not very robust on this particular model. You see not much goes on there. I do think that is a little bit unlikely. If that cap does remain fairly strong, though, and we saw in the soundings that cap is really, really strong this morning with somewhat nebulous cap erosion mechanisms at play, then we could see a bit more of a quote-unquote cap bust here, and storms may struggle to develop there across northern Illinois. But I don't think that's going to be the case. I think we will get robust convective development. The question, again, is whether or not it will be surface-based. But those storms move off to the east. We get additional development, again, along the cold front farther into the Wednesday morning time frame. So that's going to do it for this video. Once again, level 2 out of 5, slight risk for southern Michigan, much of northern and eastern Illinois, all of Indiana, the western half of Ohio into northern Kentucky. All hazards on the table for today. We do have that tornado threat that is in play. 5% tornado risk within the slight risk area. Does include places like Chicago, Peoria, Springfield, Evansville, Louisville, Indianapolis, Fort Wayne, Cincinnati, under the gun for that greatest tornado threat. Damaging winds also a threat as well. And large to very large hail. 15% hash area includes the Chicagoland area, Peoria, Evansville, over to Indianapolis, Fort Wayne, southern Michigan, under the gun for a large hail threat. And the very large hail threat is going to depend on if storms are elevated. Elevated storms tend to be better at producing hail. They're rooted above that stronger low-level shear, and with enough robust instability in place, we could see some pretty large hailstones here out across this region today, especially up here on the northern side of this hashed risk area. So northern Illinois, northern Indiana, southern Michigan, including Chicago, Fort Wayne, Gary, Indiana, places like that, would have the best chance of producing some large to very large hail, especially with those initial supercells that formed along the warm front. Tornado threat is there as well, again, but that is going to be highly dependent on the degree of destabilization in the low levels. We saw that very strong capping inversion in place, very strong elevated mixed layer, with not a really strong trough to erode the capping inversion. How much cap remains going into the evening hours is in question. If we can get full destabilization, a little bit better than expected, then we could see a better chance for tornadoes, especially out ahead of the surface low. So northern Illinois into northern Indiana, as far as southern Michigan, may have a threat for a few tornadoes there before the mode gets a little bit more messy. Then we could have some spin-up tornadoes overnight as the storms fire along the cold front down here in these to the south and southwest, central to southern Illinois, southern Indiana, northern Kentucky, as that will be as the cold front moves through in the overnight hours. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.